Hello guys and welcome back into my YouTube channel, and in this video I will tell you how to approach recursion problem, how to solve it. So without wasting any time, let's get started. And in this video I was gonna take the example of house robber problem, and in this problem we have an array of coins present in each house respectively. So what does that mean is it's telling that house at 0th index have 1 coin, how that house at first index has 9 coins, and so on. I have marked the indexes above each house for better understanding. So we have to find the maximum number of coin we can rob after visiting each house. So if that was the problem, the answer would be simple. Uh, Visit each and every house and grab all the coins and get the max coin. But there is one condition. The condition is we cannot rob adjacent house. So what I mean by that is if I rob this house, I cannot rob this or this house. So that's our constraint. So with that constraint, we have to visit each and every house and rob houses and get the max number of coin after visiting each house till the end. So that is our problem. So I can say we the problem is start from house at 0 index, visit each house till last index and get the max number of coins. Okay, can I subdivide this problem? Okay, so in recursion our first goal is to find the optimal subproblem, optimal, or I would say complete subproblem. What I mean by that is, let's say this was my original problem. I modified the problem. I would say, okay, what if I start from first uh, this house and visit till the end and get the max number of coin. So I I minimize the problem by one house and still the problem is same. See, so I started from house 0 and went till the end, so it's same problem. So I can say that start from ith house, visit till the end and get the max number of coin. I can say that. Yes. So that would be like si represent start from ith position, go till the end, get the max coin. This would be our sub problem. Yeah. Okay, so this means we are starting from s0 and going till the end. This is s0. S1 would be starting from I going till the end. S2 would be starting from second position. Sorry, second house and going till the end. So that's what this means. I start from I, go to end, get the max coin. So this our sub problem. Now let's verify if this sub problem is complete sub problem. What I mean by this is, let's say we are solving for I s equals to 1. Okay, this is 2, right? Yeah. So in order to solve for s equals to 1, I can say, so I can get max coin from starting from 2 to end by s2. Okay, now only this house I haven't visited. I visited till 2 to 4, get the max coin. This house is remaining. Okay, what to do for this house? Either I can rob this house and answer would become this, or I can leave this house and answer would become this. But this is or. I still haven't got the solution for S1. So what is the solution for S1? I don't know. I don't know. Either I can loot this, rob this, or leave this. I need some more information. What information I need is, have I robbed this house? This one. Zeroth house. See, if I rob this house, then this would be the answer, because I cannot rob the current house. And if I skipped this house, then I can rob the current house and this would be the answer. So our sub problem does not have all the information. It only has the I starting position, but that's not enough. I need more information. So what I can do is I can modify this by saying I have ith plus I have true or false. So what does this mean is I have ith, so I have to start from ith position, go till the end, get the max coin, given this is the new piece of information we added, given we have previously robbed the previous house we robbed or no. So this would be true or false, which we will get here. Okay, so now things gets different. Now things are different. Let's say I want to solve for si. Now there are two s1 now. Either I can solve for s1 t or I can solve for s1 f. What does that mean is either I am starting from I when previous house is looted. So the answer would be s of 2. Not s of 2, we have to provide the state also, this true and false also. So the answer would be as of 2, and we cannot rob the current house, so this would be false, because for s2 previous house is s1, which we are not looting right now because we already looted s0 house. It is t. Okay, I hope you understand this. But so we cannot loot the current house, so the answer would be s2 of f. Let's say for this scenario s1f, this means we haven't robbed the previous house, so now we 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 have current house as well, so we can do s2 2 and current house we can rob, so we can rob current house. So we have robbed current house value is 9, so this is the answer. Or we can again skip current house and the answer is 2 and f, and we have to take the max of this because both the options are valid. Both the options are valid. I can either do this or do this. Okay, now you will ask me in previous when we were calculating for s1, we had this same thing, 9 plus s of 2 we can do, or s of 2 we can do. We can take the max of this. Why we haven't took max in this case? Because see, in this both the scenarios are possible. This is also valid, this is also valid, because we haven't robbed the previous house, so we can loot this. This is a valid scenario, and we can skip another house again, so this is also valid scenario, so we can do this here and get the max of these two scenarios. But here we don't know if this is valid or no, because we don't know if we can loot the current house or no, because we don't have any information about previous house, have we robbed it or no. So here we have two options, but we don't know which one is valid, so we can't do this here. But here we can do this because both of them are valid. So we are getting answer. So this is our complete state because we have all the information we wanted, and we can calculate for both s1 of f and s1 empty both. So let's say this will give us a finite answer, which is x4, and this would also give us finite answer because s2 of t we can calculate. Maybe it can be x1 plus 9, or x2 and f also. X2 of f we can also calculate, which will give us x2 plus 2, only 2, there is no plus, and the max would be, let's say, x2. So answer for s1 of f is x2, and s1 of t is x4. So we are getting answer for our state. So I think this is complete state. We are not in a limbo. Now now there is one base case we have to mention, because otherwise it will go till end, like it will calculate s1, s2, s3, f4, f5, because s1 require s2, s2 will require s3, s3 will require s4, so it will go on. But at the end, when it will reach s6, so no matter s6t we calculate or s6f we calculate, both would give us 0, because there is no sixth house. So it does not matter we rob this or we didn't rob this. If we start from here, ith here, there is no house here. So the answer would be 0. So this would be, so here the recursion will stop. Well, see, so we can say when s of I is 0, when I is greater than length of array. And here our recursion is getting us answers for all the states. So yeah, so our base state is correct. Just a heads up, this would be a theoretical video. I will explain you how to get the uh, complete state, because after getting the complete state, the coding section, the writing code would be like easy. I will show you in the next part how to convert this state into code. Okay, so our final state would be like this: si of t or si of f. Si of t would be s, so si plus 1. We have robbed previous house, so we cannot rob current house, so 1 comma false, we are not robbing current house. Or the answer would be max of, we are not robbing current house again, because it is valid scenario. Or we can rob the current house 9 plus I plus 1, and we have robbed the current house, so true. So this would be our final sub problem state. So this is our main goal. When we solve recursion, we have to find the final recurrence. This is called recurrence relation. What I've written here, this is called uh, rec recurrence relation. Okay, so our main goal is to find this recurrence relation when we solve a recursion problem. Okay, now let's do one more thing. What if I would say, like, we can optimize this recurrence relation further. Hmm? Okay, okay, so let's this was a problem. Okay, now previously when we said si, we said we'll start at ith position, we'll go to and get the max coin, right? We said this, but then we fumble upon this, like, for let's say for s of 1, I said either I can write n plus s of 2 or s of 2, which one is valid. So what we can do is, instead of passing each I, like, instead of passing any I we want, we put a condition on I. So similarly, what we passed t and f, let's pass I with a rule. What I mean by this is, so let's say I, so S of I would be like, either I can, like I passed f t or f, here also I can pass I or I plus 1. Okay, let me explain you what I mean. So let's come to our example. Let's say we are calculating for S1. Okay, so when there are two scenarios. Okay, we rob first house, we don't rob second house. Okay, we rob the current house, we don't rob the current house. Okay, so what I say, what if instead of S2 I write this? If I rob current house, instead of passing TF, I pass modified. Previously, I was passing S2 and S2 in both the cases. See this? Si plus 1, Si plus 1. So in both the cases, I was passing S2. I robbed the current house, so I passed T. I skipped the current house, I passed F. What if I combine both of them and pass single variable I? So what I mean by this is, so I rob the current house, and so it's true. So so instead of true, I pass I plus 2. Hmm. So what I mean by this, I I robbed this house. So why would I calculate S2? Because I cannot rob this house. So why would I calculate S2? I can directly calculate S3. There is no meaning calculating S2 because I cannot rob this house second number. So why would I call uh, S S I plus 1? So I'll call S I plus 2. And if I don't rob this house, let's say I don't rob this house, then I should calculate S2, because I can rob or skip this house as well. I can rob or skip this house, both the scenarios valid. Then I should calculate S of 2. Okay, so now I'll calculate S of 2. So now this works. This sub problem works. S of I starts I and till I till end till max coin. Now you would say, uh, now you would ask this question, like, okay, if that's the case, then let's say we are calculating S1 and S2. If we see, we have, when we write this, when we are passing I plus 2 and I plus 1 in this case, we are in building this, this true false and this uh, criteria inside the I. What I mean by this is, if you are calculating Si or S2, you only calculating S2 because S0 was asking S2. See, in this case, if I put correct values, so as 1 plus 2 would be 3 and 1 plus 1 would be 2. So see this. This is also valid, this is also valid. But before what we were writing was S1 equals to 9 plus S2 or S2. We didn't knew this is valid or this is valid. We didn't knew. That's why we introduced this true and false. But if we modified the index by plus 2 and plus 1 and combine this true and false, now this is also valid and this is also valid. See, S3 is also valid. I can skip the next house and go to the plus 2 house, and this is also valid. So that's why I can do this. I can do max on this, but I cannot do max on this. So now this is also completely valid, which makes this also completely valid. So now this state is completely valid. Condition is we are passing I plus 2 if current house is robbed, and I plus 1 if current house is not robbed. Here our condition was true and false. Given previous house was robbed or not, we had this information, but this time we are sending this information inside I by manipulating it by plus 1 plus 2. Okay, I hope that makes sense. So we can do single variable, and here the final recurrence relation was like this: SIT and SIF. We can combine ITIF and write single recurrence relation like this: SI, and it would be max of current house coins, current coin, plus S of I plus 2, or S of I plus 1. Both are valid, that's why we can do max. So this would be our final recurrence relationship. So that's what we wanted to know. Now we can convert this recurrence relation in code, and again the base case would be same, because as 6, if we are calculating as 6, there is no sixth house. So there is no sixth house, or so it would be 0. And if, because let's say S5 we are calculating, S5 would be current, like coin at number 5 is 4, so it would be 4 plus S of 7, or S of 6. This will return 0, this will return 0, so S of 5 would be 4 plus 0, or 0. Max of this is 4, so S of 5 would be 4. So S of I would be 0 if I is greater than length of array. Same base case what we have written above. uh, we have written this base case, right? We haven't. I think I rubbed it. Here also, if S of I is 0, this would be our base case when recursion will stop when I is greater than length of array. I don't know, I think I erased it. Okay, so this was the solution for house robber problem. Let me give you another example of another problem, simple problem, but to give you an idea. So Fibonacci series. So Fibonacci series is what a Fibonacci series is this: 0 1. So these are fixed, these two are fixed digit in the series. The the first digit, sorry, this is the index 0 digit, this is 1 digit, 2 3 4 5 6. Okay, so this starting two digit are fixed, then third digit is the addition of previous two digits. So 0 plus 1 is 1, third is 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8. So this is, and so on. This is Fibonacci series. So I can write, if I'm standing here, similarly when I was standing here at here, I can say my problem start from here, I have to find till end, and this would be my sub problem. Similarly, I can say if I'm standing here as I, my answer would be previous digit, which is as of I minus 1 plus as of I minus 2. These two, I minus 1 and I minus 2, summation of these two. So this would be my recurrence relationship. How I can verify this? So this was a complicated, this is very simple problem. I can give you a simple run through. So let's say I want to find as of 2. See this one. Let's say I want to find this digit, and or not even this, I have to find this digit. As of 4 I want to find. Let's say I want to find as of 4. How would I find it? As of I minus 1, I minus 1 is 3, and I minus 2 is as of 2. So I have to find as of 2 and as of 3. As of 2 would be as of 2 minus 1, which is 1, 2 minus 2 plus as of 0, and this would be as of 3 minus 2 plus as of 3 minus 2, 1. So as of 1 is 1, as of 0 is 0, 1. So as of 2 is 1, and as of 2 is 1, we got it from here. As of 1 is 1, we got it from there. So 2, as of 3 is 2. As of 3, as of 2, put the value 1 and 2, yeah, 3. As of 4 is 3, it is 3, see, it is 3. So our answer is correct. So this means our recurrence relation is working. The base case here was as of 0 is 0 and as of 1 is 1 always, because we needed that base case to solve this, to find the as of 2. Similarly, this base case will stop the recursion, because as of 6 and 7 we needed, in which both will come 0, and we'll get as 5. See, we calculated as 5. Similarly, when we'll calculate as 4, we will need as 5 and as 6 here. So recurrence will work like this. So that's how it will work. So basically, whenever you do recursion problem, you have to stand on ith position and then figure out what I have to do here on ith position. Like here, I had to find this digit on ith position. To get this digit, I needed the answer for this and this. See, similarly here, I st- I stood here on this second, and then I needed to find the answer of this problem. Like I have to rob starting from second till the end. Similarly here, stood here, I have to find this digit. To find this digit, I then saw like Fibonacci series definition, and it is the sum of previous digits. So I wanted previous digit plus previous to previous digit. So I did this. In above case, I wanted to solve this like max coin from here to here. So I found like if I want max coin from here to here, what if I find max coin from here to here? Then I can add this in the result. Then I have to add or skip this into the result, and I got my two recurrence relation, this or this. Where is this? So this was a long video. The code conversion I'll show you in the next part, otherwise this video will become very long. I hope you like this video. I hope you understand this explanation. I'll see you in the next video. Bye bye. Tata.